There are two ways we can go about this question. The first one is to actually list out the cases for these 4-digit numbers. So we know we have to have at least a 2 and a 3. So we have these two spots that can be filled with 1, 2, and 3. So what are my choices here? It could be 1 and 1, 1 with itself, 1 and 2, 1 and 3, and then 2 with itself. Then 2 and 1 is already counted, so I just need 2 and 3, and then 3 and 3. So the possible cases are, and I'll write it like this, 1, 2, no, this stays at 2, 3, 2, 3, 1, 2. So this piece is the same, 2, 3, 2, 3. So we're just arranging these 4 digits. And of course, we have these repetitions. So how many different ways I can arrange this? It's 4 factorial over 2 factorial because we have this repetition. 4 factorial is 24 over 2, that's 12. Do the same here, that's also 4 factorial over 2 factorial, 12. That's also 12. This is 4 factorial over 3 factorial. We have 3 2's here, which is 4. Then this is 4 factorial over 2 factorial, 2 factorial. This is going to be 6, and then this is 4 factorial over 3 factorial, which is 4. So I have to add these 6 cases. So 10, 14, 26, 38, and then 12. It's 50, and that's the answer. So you can just kind of do it out brute force, considering that there aren't that many cases. The other way is to do the complementary approach, which is you count where this is not the case. So for example, if you're just creating 4-digit numbers where we can use 1, 2, and 3, no restrictions, then I have 3 choices here. It could be 1, 2, or 3. 3 here, 3 here. Because remember, repetition is allowed, meaning 2, 2, 2 is acceptable. So the number of such 4-digit numbers are a product of 3 to the power of 4, which is 81. Now we'll look at cases where 2 doesn't appear. So all we have is 1, 1, and 3. So here I have 2 choices, 1 or 3, 1 or 3, 1 or 3. So I have 16 such numbers. Same thing if I do 1 and 2. Because remember, I'm looking for cases where this isn't satisfied, because we need at least once here. We don't have 2 and 3. We have just 1, 2. So that would be, again, 2 choices, 2 choices, 2. So we'll have another 16 numbers. So we have a total of 32. Now, the key thing to keep in mind here is that in this example, this number is present, 1 appearing 4 times. But here also we have 1 appearing 4 times. And so I've double counted that. So I have to subtract it once. That means there are 31 such numbers where 2 and 3 doesn't appear at least once. And then I take 81 and then I subtract 31 and I'll get 50. I didn't do it this way, but in some of the questions where this counting is too large or too complicated, always look to think about the complementary event, meaning event where this doesn't happen. So yeah, it is a hard question. Just to kind of just show you what my actual work looks like. You can see kind of brute force. I listed more examples here, and then I had to strike those out. So obviously these are the things that will happen under exam conditions. And I think I made some mistakes in calculations, but eventually I got the answer. So this is the reality of what will happen in the exam. Sometimes, elegance goes out the window. That happens. But of course, if you can do it cleanly, that's the preferred way, and you will do it in less time as well. So that's what we're striving for, but just recognize that there's all these other things that will actually happen in the real exam. So to summarize, the answer is 50.